All right, we have the last bit of vocab before the next formative. Rate of change. And rate of change is a description of how one variable changes in relation to another variable. We'll use this in terms of slope, which we've already talked about, so you're already familiar with the concept. So we're looking at, say, slope of 2/5, right? Remember, this is the change in y over the change in x. So again, it's a description of how one variable changes in relation to another. And if you remember then, this one would represent going up 2, right? And to the right then 5. So again, rate of change. Alrighty, so talking about an equation in two variables. So we're going to get down to where we're going to talk about graphing equations and how to use those equations. Obviously, we started out with slopes, so you understood with that. That's the main part of the equation. But an equation with two variables, usually x and y in this case, one on my arrow, there we go, typically graphed on a coordinate plane. Now, there are many forms of a line. If you were, next year you'll have to learn all the different forms of line. For this year, we're just going to talk about what's called the slope-intercept form of a line. It might look like this: y equals 2/3 x plus 5. So an equation in two variables. Notice I have two variables here. I have a y and an x. You might recognize this part, the fraction part. That's the slope, and we'll talk about that in a little bit. But again, equation in two variables. And this is something that's actually pretty easy to graph, you'll see. The solution of an equation in two variables, any ordered pair that makes the equation true. There are many answers. In fact, there's generally infinitely many answers. I might give you an example. Y equals 2x plus 1. And we're going to have a day in class where we'll also play with these. We use an app called Desmos, and you'll kind of get a feel for how they work, how they're different from each other. But anyway, any ordered pair, which we talked about ordered pairs today, we'll review that today in class, that makes this a true statement. So if I were to put in the following point, if I were to put in the point 0, 1, so again, the point 0, 1 satisfies this. And we're going to go through today how to graph all those points. If you remember that, though, I know it's something you learned before. So this point right here, 0, 1, right, is along this line. Now, if I were to graph this, and again, we'll spend some actual time on this soon, this line would go through, if you use the slope, up 2 over 1, right, up 2 over 1, so on and so forth, that obviously you can see a line emerging from all of this. If I were to follow like this. And we're going to learn how to do that, how to graph this based upon just looking at this and be able to say, hey, look, I can make a line that looks like this. And any point along that line, I do apologize, not super straight there, any point along that line actually satisfies this statement. And there's an infinite number of them. They include fractions, decimals, technically irrational numbers, all kinds of them. So again, to bring that point back home, a linear equation is an equation whose graph forms a straight line. So again, another example, looking kind of like the last one. Y equals 1/2 x minus 2. Notice there's kind of a pattern here to how these look. And again, to point out certain parts of it, and I'll make a bigger deal of this as well. This is the slope. This is what we're going to call the y-intercept, and we'll go over that soon enough. But it's nice because in this form, you go, oh, well, -2, that's 0, -2 is the point. And then I can count the slope, in this case 1/2, which is up 1 over 2, right? Up 1 over 2. And you can always also reverse that too and go backwards. And it makes a straight line, something that you can graph. And that's where we're headed with all this. So a linear equation, an equation that makes a straight line. Now, two variables in this whole thing, independent variables and dependent variables. In this case, when we're talking about the, like say y equals 3x minus 5, the x is the independent variable. It's called the input. So the x is the independent variable. Again, it's called the input. Right here, independent variable, the x. Also known as the domain, and again, it's x for our purposes here. So use this as your example, right? Now, the dependent variable is the one that depends on the other one. We also know this as the range, and this will be the y variable, the input-output idea here. So if I were to give you, say, y equals 3x plus 4, you could even make a table out of it. This will serve as your example here. So if I put 0 in for x, well, that means y equals, or y depends on, in this case, 3 times 0 plus 4. Well, 3 times 0 is 0, so y equals 4. Notice when I pick an x, the y comes out, right? So if I said, if I say I put in a 1, y equals 3 times 1 plus 4. So y equals, what, 3 times 1 is 3, plus 4 is 7. So notice independent's the input, that's the domain, and dependent, that's the output, that's the range, that's the y. So again, dependent is generally the y variable.